First-person camera in Unity. This video is going to walk through creating a first-person perspective project, as well as adding some 3D objects to the scene just for simple interactions. So we're going to start by creating a empty game object, and we're going to rename it player. So let's go over here in the hierarchy view, create a new game object, create empty. Right here gives it the default name game object. Over here in the inspector view, going to rename it to player. Then clicking out of this will confirm that name for us. And now we have a game object called player. So first person perspective or first person camera is actually kind of a trick of how game objects are used within Unity. So what we want to happen is that when we move the player game object, it also moves the main camera. So we are going to create eventually some controls where when we move the mouse or use the horizontal or vertical movement, that is either the arrow keys or WASD within the keyboard, we want to then move the player. And because the camera is attached to the player, also moves the camera at the same time. So we're going to start to move in that direction by making the main camera right here a child game object of a parent called player. So we have player right here. I'm going to click and drag on main camera and make it a child game object of player. This will put main camera underneath the player game object and will allow us to soon, when we write some code, change its position. So to start then, let's look at how positions work within the transform component of game objects within Unity. So we need to understand a little bit how three-dimensional space works within Unity. So I have the main camera selected right here over in the hierarchy view, and over here in the inspector view, I can see its components. So let's pay attention right here to this position right here. It's at 0, 1, -10. If I click on this little blue thing right here and drag it, notice how Z changes. It changes right here into positive values. And if I move it backwards, it changes into negative values. So movement forward or backwards for us will be along the Z axis. Forward will be positive directions in Z. Backwards will be negative directions in Z. So if we wanted to move up or down based on our current perspective, it would be Y. Moving Y up is positive, moving Y down is negative. And over here in X, moving sort of left or right would be over here, positive, or over there, negative based on our current perspective. So what we then have to start to put into play, and we will do some math demonstrating this, that we will move forward and backwards along the Z. We will not necessarily move for the Y, because that'd be kind of jumping, which we're not going to necessarily do right away. But turning would be along the X axis, moving left or right, and forward or back will be along the Z. So we need to understand that perspectives because it's different than thinking of 2D space. In 2D space, or at least classical 2D space, we can think of, for example, if the cursor is moving all the way up into the upper left, would be larger numbers, or down here, or would be smaller numbers, and moving all the way to the bottom right would be higher numbers. So the mouse position of X and Y is different than the interpretation of our perspective within Unity. We're going to have to do some tricky math to actually flip those numbers when we get in and doing the math on moving the camera around based on the cursor. But let's just currently understand that to move forward is Z, to move left or right is X, based on our current perspective. So all of that said, let's actually add something for us to look at based on the camera. So right now we have an empty player game object and we have a camera, and that's fairly exciting as things go, but we need other things within this scene for us to look at. So let's go ahead and add a floor. So we're going to add a floor by adding a plane, a 3D object. Over here, add a new 3D game object and come down to plane. A plane is a flat game 3D object. So instead of having depth right here, it's sort of flat and it allows us to basically create a floor. So by default, its scale is 1, 1, 1. Let's change this and make this 20, 20, and 20. So expand out in 20 directions, 20 units. and basically create a huge floor for us to look at. So if we move over to game view, we currently see we're not really looking at anything. Well, that's a little bit strange, right? We should be looking at something. Well, there's a little bit of a problem. The plane is sitting at 0, 0, 0. Our main camera sitting at -1, -0.3, and -4. Let's reset this positions to 0, 0, and 0. Well, now notice we're still not actually seeing anything. So let's actually move this up, right? 0.5. So now we're at positive, moving up y, and now we can actually finally see the plane right here, because now we are above it in the y-axis. The plane has a position of 0y, and our main camera has a position currently of y 0.5 units. We are 0.5 units above the plane, and we can now see the plane. So this is something else we need to keep in mind. Moving in three-dimensional spaces, that objects are in relation to each other. Our plane now is underneath, that is, below on the y-axis. So let's add another object to this scene so we have something in reference to when we start to add some movement, which is coming soon. So we have a plane right here, and now we want to add some more 3D objects. So let's just go ahead and add a cube. So down here, 3D object, cube, and it will add it at 0, 0, 0 for us, which is somewhat helpful. But notice how it kind of intersects with the plane. It's about halfway down. So we can solve this by moving it about halfway up right here, and now it's sitting the same position we are. If we move over here, we kind of can't see it because it's the same position we are. So over here in Z, let's put it at 10. And notice it moved it right here. So if I shift over to the game view, we see it's at 10Z, or roughly 10 units in front of us along forward or backwards movement, again, along the Z axis. So we see it's at Y 0.5, or halfway up, and it's about 10 units in front of us. Well, that's pretty cool. So now we have something to look at. So if we were to play it, you see, yeah, squares, cubes, 10 units in front of us. Cool. Well, this now gives us something in reference to some future movement we're about to put into play. So to start to move it then, we're going to need some other things coming into play. So to start that conversation, we need to remember how Unity works. Unity works through Entity Component System Model, or ECS. We have currently a listing of entities over here within the hierarchy view, things like the player, things like the plane and the cube, and it has corresponding components we see over here in the inspector view. We want to interface, that is, work with two different systems, and these are two different systems within Unity. We want to work with the collision system, or things intersecting in their positions within world space, and the physics system, we want to be able to move something over time. So to start to interface with those two systems, we need to remember that components talk to systems, or systems talk to components, depending on how you want to look at it. So if we have entities, and entities are collections of components, then we need to add corresponding components to some entities so they can talk to the systems we want. The two systems we want are the collision system and the physics system. These are mostly going to apply to the player, but will also apply to other things. So you may have noticed when we added the cube, it added something called a box collider right here. So this just says that there's a collider around this entire box. So each sort of side of this is its own box collider. Come down to the plane and just add the same thing. So it starts with a mesh collider, but we don't want to mess with meshes. I'm going to add a component, physics, box collider. This is a simple box collider, and notice it highlighted the edge of the plane. So our cube has a box collider, and our plane has a similar box collider. So let's come over to player, and we want to add a similar thing, but not a box collider. We're going to add a capsule collider. Add component, physics, capsule collider. And notice, and I can zoom in a little bit here, you see it added at a similar thing about halfway down. So we want to say 0, and then move it halfway up a unit, 0.5. Now it's above the plane that's at 0, and we can leave Z fine. And zoom out a little bit. So as we see here, our camera is just above this, our capsule collider we added to the player game object. So what's the difference between a box collider and a capsule collider? It has to do with kind of what it's looking at. So a box collider is looking at basically the box, the bounding box of the certain objects based on their position. The capsule collider provides what is kind of like a sphere, so a circle in three-dimensional space, but with extended ability to either extend along the horizontal or the vertical. So in other words, we can create something that's a little more like kind of a person size within space. People aren't really boxes. People are kind of more like capsules, really, where they're kind of long and then they have curved edges. So, okay, we've got our capsule collider. This is pretty cool. But again, we needed that one extra system. These are our collision systems, but we also need our physics system. So there are a couple of different ways we could approach this, but one of the easiest ways is to use something called a rigid body. The rigid body just means that it doesn't change when it collides with things. It is rigid. So a rigid body can be added through adding components, coming down to physics, scrolling down just a little bit and looking for rigid body. So now we have a rigid body and we have a capsule collider. We have our capsule space and we have our rigid body, and our rigid body is going to basically provide us access to the physics system and the capsule collider access to the collision system. So finally we have these, and so now it's actually time to write some code to interface with all of these different things and to adjust various values of the components as part of a scripting component. So that scripting component is important there because it means we need to add another component. So let's go ahead and do that. With the player selected right here, I'm going to come over to the inspector view and go to add component, scroll all the way down to the bottom, new script. I'm going to press down twice on the arrow to move me from the search down to this. And I'm going to rename this what it does. So this is the player controller. It controls the player. I'm going to click on create and add. So two things are going to happen right away. It's going to add a new scripting component, which Unity is doing in the background right here, and named player component or player controller right here as a scripting component. And it's going to also add a new C# file over here, matching the name of that. I'm going to go ahead and open this C# file. I'm going to open Visual Studio. And it's going to provide us with two initial methods. They are start and update, which correspond to the systems and the messages from the systems within Unity. Again, we need to remember that Unity works within the entity component system model. It is sending messages, communications from its systems to its components. This is a scripting component, which means it can listen to those messages from the systems. And in fact, we see this right here, Unity message, 0 references, Unity message, 0 references. The use of frame right here signals to us that this is start, which is called before the rendering system runs, and update, which is called every time the rendering system runs. So these have to do with the rendering system. Right now we can use them, but we're also going to tap into the physics system here soon, so we can do some physics calculations as part of that. So we're going to need a couple of different things to start. So I added a capsule collider and I added a rigid body and I moved the camera and we've got a whole bunch of stuff going on. So let's add some initial fields, some initial properties to this object, and then we're going to access them across methods. Now remember, within C#, if we want a value that exists outside of any one method, it needs to exist as a field, what C# calls properties of the object. In other words, we put them outside of any existing method and they can be accessed inside those methods. So the first thing we're going to do is go ahead and add a field for the camera, because we're going to have to adjust the position of the camera corresponding to the position of the player game object in the future. So let's go ahead and start to work towards that. Call this camera because that's what it is. That's its data type. I'm going to call this cam. Now it can be tempting to call this camera, but don't do it. Reason why you don't want to do it is because of some previous versions of Unity where camera was an existing field on the default mono behavior game object. And if you use camera, Unity is going to complain that you're using old fields or old properties. We're not doing that. We're calling it cam. So just, we have to call it cam or call it something other than camera, all lowercase, or Unity will just complain. So that's the little qualifier there. So what other things are we going to need? Well, I'm going to need some type of movement. So I'm going to go ahead and create something of a vector 3. And I'm going to call this move direction. Go get my direction. Now, I'm calling it this ahead of time because I'm actually going to do some type of vector mathematics as part of my movement. So instead of getting one value and doing a move and getting another value, doing a move, I'm going to actually combine these and tell Unity to do the math internally and then move something within world space. But we'll get to that momentarily. The other thing I want to go ahead and add is a rigid body, which we'll just call RB. So now we have access to a camera, we have access to a move direction, which we're going to use to do some vector mathematics. We have access to a rigid body, or at least we have possible references to all these things. The first thing we want to do before any rendering starts, start is called before the first frame update, is go ahead and associate these values, these fields, with their parts within this game object. So, for example, cam should be a camera. But the camera is not a component of the player game object, but of its child main camera. There's a camera component that's part of main camera, and main camera is a child component of player. In other words, I want to get component in children of camera. And I would say, okay, go to your game object. Remember, this is a scripting component. So component, go to your game object. From your game object, get component in children. Look through all of your children and find the first camera. There's only one camera that's part of main camera, and so we will automatically get that. Now, this is going to be slightly different. For the rigid body, we will say, hey, get component, not children, get component, because a rigid body is part of the player game object. And we're looking for a rigid body, and that will associate those values. So go into your children player, right, the player game object, find the camera, go ahead and save that value. In your components, find the rigid body, save that value. So we've got the camera and the rigid body currently covered, or at least they are currently. So I'm going to go ahead and save this file. For me in Windows, that's Control S, just so we always have the most up-to-date version of our file. We're not making a bunch of changes and then accidentally losing them. So now we want to do something, an update. So this is where we start to tap into the physics system, at least initially. We're going to do some stuff with the input system and then work towards doing stuff with the collision and physics system. But let's start with the input system. So what we want is we want the current movement along the horizontal axis, what Unity defaults to. Then we want movement along the vertical axis, what Unity defaults to. And I see this what Unity defaults to because this is important considerations to make. So let's pause here and go look at something Unity kind of sometimes hides from people. So when I say horizontal and vertical input, what I actually mean is we can go down to Edit, Project Settings, Input Manager, and Axes right here. And I say horizontal, clicking right here, I mean key or mouse button X-axis get motion from all joysticks. Down here for vertical, I mean key or mouse button X-axis. Notice up or down, or basically WASD right here, ADSW. So when I ask for get axis horizontal, it's going to give me a certain value. When I ask for get axis vertical, it's going to give me a certain value. Where it's getting the values from is within the input manager right here of the project settings. So we will say get horizontal or get vertical, and what it will actually do is pull the information from inside of the input manager. So let's close this and move back over here to the code. So what I want then, horizontal is equal to input, again, input system. I just mentioned get access horizontal, I just looked at, and float, vertical, input, get X, vertical. So this gives us a shortcut. So we can either press WASD on the keyboard or the arrow buttons on the keyboard, or if there's a gamepad connected, the left or upmost joypad based on the Unity's default settings. So these are all part of the horizontal and vertical sort of defaults Unity has baked into it. When we say get access, it looks at the project settings, it then looks at the input manager and supplies those values for us. So these values will be in the range of -1 to +1. So what we want to do is we want to say, okay, we want to move within world space. World space is made up of 3 different positions: an X position, a Y position, and a Z position. Or what we can also think of these as a vector, X, Y, and Z. We can compute what is known as a normalized vector by doing the math and then telling Unity to normalize it for us. So that's what we're about to do. I want to say move direction is equal to, and now let's do some math. I say horizontal multiplied by transform right. So horizontal multiplied by, so horizontal again, -1 to 1 multiplied by the red axis of the transform in world space. So whatever Unity considers to be its basically left to right, plus vertical multiplied by transform forward. So whatever Unity considers forward and backwards. Now, with that all done, we're going to give it one more thing and say, okay, normalize this for us. So what just happened? Well, we told Unity to perform some vector math. We said, okay, take whatever you get from the input axis horizontal and multiply it by whatever you are assuming the left to right is. Then add that to whatever you vertical get, -1 to 1, multiplied by whatever you consider the transform forward and back to be, and then normalize that, do all the internal vector math for us. What this allows us to do is if we decide in the future we want to change the default transform right and default transform forward, for example, if you want to completely change to perspective within Unity, we don't have to change any code because we're built on what Unity assumes these to be. So instead of adding some other additional code, we're saying, okay, move this along whatever you consider to be the left to right movement, and then move this along whatever you consider to be forward and backwards. So I mentioned it, it's Z and X for us currently, but Unity will now take care of that math for us. Okay, we have our move position all figured out, and this is done within the rendering. We now want to access the physics system or start to access the physics system via a Unity message. So this will be called beginning before the first frame. Update will be called every frame. Now we want to tap into messages that are part of physics system. So void something called fixed update. Fixed update runs at a fixed point, hence its name fixed, as part of every game loop. The game loop starts and systems run one after another, after another, after another, after another. This is at a fixed position within that. So anytime physics calculations will occur, we want to go ahead and have them occur right here. So we want to say the rigid body's velocity is equal to the move direction, calculations it did for us, times time delta time. So what does this mean for us? It means whatever time happened between frames that is part of the rendering, we're going to go ahead and incorporate that. So this is usually microseconds. It's usually a very small number, but whatever happens, this is just the completion time in seconds between the frames. Go ahead and calculate the velocity, again, something over time, is equal to whatever our movement is multiplied by the time delta time. The time between frames gives us the normalized vector, or multiplied by the normalized vector. I'm also going to include something else. So let's actually increase our movement speed by quite a bit. So I'm just going to say right here, let's just make it 1,000. So our movement speed is currently 1,000 times delta time times movement direction as part of fixed update. Just a whole lot of things, basically just saying like, hey, I want to move around when I press these buttons. Let's move back over to Unity and look at what this is going to do for us. Go ahead and play this scene. And there's our cube. I'm going to press W. Whoa, we flipped, right? Press S. I moved all around. Let's come back into here. Restart the scene. I'm going to press A. And we rotated and we fell on our side. What in the world just happened? We are a capsule. We're capsule. We rolled, but we don't want to roll. So what we're going to do is set some constraints on the rigid body. I'm going to say, hey, I know that you think you're a ball and you want to roll around, but actually freeze your rotation on X, Y, and Z. Don't roll, right? We're a capsule, don't roll. So let's restart it. I'm going to press W. I move closer. S, move farther away. A, move to the left. D, I move to the right, move to the right, move to the right, right, forward, forward, back, back, forward, forward. Cool. So now we're moving along as a capsule within space, but we're not rolling. So we prevented it by setting the constraints of freezing the rotation. So we're not rolling around as a ball within space. So very cool, right? So far we can move forward and we can move back. We know our forward and back is along the Z axis and our left and right is along a different axis as we saw. So now we want to incorporate mouse, right? We want to be able to move the mouse around, and as we move it, it moves the first person camera. Our camera is attached to our player game object. So we're moving our player game object with either WASD or the arrow keys, whatever is considered horizontal input and vertical input. But now we want to get that mouse input and start to incorporate that as well. That requires some additional information. So I mentioned that the position of mouse and the mouse position, mouse X and mouse Y, is different than the world position within our world space. This is where some weird mathematics comes into play. So what we want to be able to do is we want to be able to move the cursor up, which means we look up, move the cursor down and we look down, move it left and we look left, and move it right and we look right. Now let's start to think about what that means corresponding to the camera within world space. So if we're looking up, then we're actually rotating Y. If we're looking down, we're rotating negative Y. And if we're rotating sort of left or right, we're rotating on another axis. So we're actually doing rotations based on the corresponding mouse X and mouse Y positions within the space. So we interpret that through our perspective as of me literally moving my mouse to the left, which means rotating to the left, moving to the right means rotating to the right, moving up means rotating in these different directions. And this is where the math gets a little bit weird, because we actually want to calculate something that's actually kind of hard to calculate within these spaces. We start to understand we can move along the Z and the other positions as we've been doing, but this requires, again, a little bit more understanding of these spaces. So let's move back into here. What we want to first do is we want to basically create some fields, some properties of this object that we're going to use throughout it. Two things that I've started to talk about here are rotation X, I'm going to go ahead and set to 0, and rotation Y, and set it to 0. Oh, and I spelled float wrong. So we're going to want to know what our rotation is for X and our rotation is for Y based on what we will get very shortly, the mouse X and mouse Y. But these will not be quite as we think they are. They will be similar to, but not quite the same. So let's go ahead and after this move direction right here, we want to get two other things. We basically want to get what mouse X is and mouse Y. Well, thankfully, if we move back over here, we go back to Edit and Project Settings, and we look at Input Manager. You see there is a mouse X, is mouse movement, X axis, and Y is Y movement, Y axis. Well, that's super convenient. So what that means, we can get here, mouse X equal to input, get axis, of mouse X, float, mouse Y, corresponding mouse Y. So mouse X input and mouse Y input, or mouse X and mouse Y, in the similar range that horizontal and vertical is. So now we're going to do something a little bit interesting. So what we want to do is we want to go ahead and say rotation X plus equals mouse X. So for every time we re-render, go ahead and keep the current position. So if we go negative, a negative rotation, decrease it. Or if we go positive, increase it. So just change it based on where we're moving. Let's go ahead and do the same thing for Y. Y right here. Okay. Now we're going to run into a bit of a problem. So if you've ever thought about the way the human head works, that we sort of rotate our vision to the left and rotate our vision to the right, we can't actually fully rotate our head because that would kind of break our neck. So instead, we kind of have a limited range of turning. We want to actually put that limitation into this project as well. And we want to say you can only rotate up to a certain point and then basically you flip around, right? Kind of the equivalent of you turn your head all the ways you can and then you just turn your body. So let's go ahead and incorporate that restriction. So we want to say along the x-axis, rotate x, we want to clamp this value. So math F for floating value calculations here. And we use clamp. We want to say, okay, rotate x to a minimum of negative 60F. So 60 degrees basically, negative, and 60 degree positive. So we see, okay, you can only move your x up to negative 60 or up to 60 or below to negative 60, basically our rotation space for our x. So let's now do something a little bit weird. We want to set the local to something here. So, okay. We want to set this up such that our local rotation of our camera is equal to our rotation along the axis that we want of the mouse. So I'm going to set this up, and I'm going to set this up a way that common sense would say it works, and I'm going to show you how it doesn't work at all that way. And then we're going to actually change it so the math works out. So let's go ahead first and set it the way that would seem to make complete sense. So we've got our rotation set up, right? Okay. So what we want then is what would seem to make the most sense. We want the camera. We want to transform it. So change its thing, change its local rotation, what I just mentioned. And then we're going to tell it to do some math here. We're going to say, okay, take this and convert it into what is known as Euler rotations. Euler rotations is local to the object. It's some vector math, basically. We say, okay, set this to rotation X, and then I don't want to rotate over any other axis, basically. So again, if I'm moving the mouse to the left, I want to rotate left negative. I'm moving the mouse to the right, I want to rotate X positive, would seem to make sense. At the same time, we want to transform the rotation of the current game object, player, which has the capsule, has the rigid body. I want to say, hey, now I want you to do some different math. And I want you to move this over rotation Y right here. So I'm going to say when I move the mouse, change it on the X. So I rotate left or right. And then I want you to correspondingly change the rotation on the Y based on us moving the mouse up and down, right? This would seem to make the most sense. We want to move the player object corresponding to the Y and move the camera corresponding to the X. Seemed to make sense. Common sense seemed to make sense. Go ahead and save this. You can notice by my tone this is not going to make sense, but we'll fix it here in just a second. So let's come over here. I want to now play this scene. So we saw previously that we could move forward W, S, A, T. Now, I'm going to look up, and it's going to turn me in a weird direction. I'm going to look down, and it's going to turn me in a weird direction. I'm going to attempt to look left, and I'm going to attempt to look right, and it's not working, right? Well, it has to kind of do with how Euler angles work in relation to the objects. There's some math involved, but the pretty simple answer is to actually flip what we're getting on the axes and set it to a different axis. In other words, this should not be mouse Y. This should be right here. This should be mouse Y, and this should be mouse X. These should flip. Get my capitalization worked out here. There we go. So when we change in a Y direction for the mouse, it should actually be the rotation on the X, and the movement on the mouse X should be a rotation on the Y. So let's go ahead and just fix this right here. Instead of just saving these values, since we're only really using them right there, let's go ahead and fix this. This should be rotation X plus or minus, and this should be rotation Y plus or minus. Okay, and we'll go ahead and take out these two code. And we've made things a little bit simpler on ourselves. So basically, we're going to sort of invert the controls on ourselves. Again, based on the X and Y position on the screen compared to the X and Y position within the game world. We're going to do one other thing. I'm going to set this to a negative rotation X. Again, doesn't seem to make sense, but it will actually work out the way we want it to. Let's go ahead and save this. Now let's move back over here. So now let's play the scene. W, S, A, D, looking down, looking up, left, looking right. Okay, so as we just saw, restart the scene. If I move the cursor up, we look up, move the cursor down, we look down, and move the cursor left, we look left, and move the cursor right, we look right. Not particularly fast, and our movement is kind of weird within the space, but things kind of seem to work, right? We can kind of fight with the thing and rotate ourselves, right? But you may have noticed something kind of interesting. Our Y was changing, right? Our Y values right here were changing in a weird way. And our cursor is on the screen, and there's some things we need to go ahead and clean up. So let's start to clean that up. What we want to introduce is a new mouse sensitivity. We want to basically say you can move the mouse a little bit and it will correspondingly move the rotation a lot more. So mouse sensitivity. Now let's go ahead and just set it to 15F. And these are values we could play with in the future. So let's just go ahead and incorporate this. Mouse sensitivity. Mouse sensitivity. So now this is now multiplied, which means I can move my cursor a lot less. Sensitivity is turned up. Now, whoop, there we go. Now it's moving even faster, right? Cool. But we also see the cursor on top of the screen, so let's go ahead and fix that as well. So thankfully, there is a cursor object right here, and it has something called a lock state. And we need to set this to cursor lock mode locked right here. So basically what it said is as soon as this starts up, right before it starts the rendering system, go ahead and lock the cursor and make it basically disappear. So we can get the cursor back by pressing the escape key, but what this allows us to do is disappear the cursor while we're playing in the scene. So the scene starts, cursor disappears. Looking up, looking down, looking left, looking right. It also stops us from being confused by seeing the cursor on the screen at the same time. So I can walk forward, and also now rotate by pressing D, move right, while also correspondingly moving the mouse and basically strafing around this cube I've created right here. Now the cursor's currently disappeared. It's locked within this scene. We can get it back by pressing the escape key. And now exiting out of the scene. So, okay, we've got most of this stuff worked out, right? But we may have noticed something else, and I started to mention the Y position acting a little bit weird. So let's notice right here, Y is kind of looking a little bit weird. This Y is 0.5 over in position. It shouldn't actually be doing anything, right? As long as I'm moving around, it shouldn't actually be any value. So let's fix that. So what we need to do is go ahead and re-add back the Y velocity within each fixed update. So what we're going to do is we're going to save Vy new vector 3 0 RB velocity Y 0. Do this calculation right here, which is messing up the Y, and then we're going to add it back in. Velocity plus equals velocity Y, and it's going to internally add the two vectors back together. So we're going to get whatever the current Y is, do the calculation that was messing up the Y, and then add the Y back in again. If we go ahead and save this, we'll notice that the Y right here will, when we play the scene, go back to what we want it to be. And notice our Y is not kind of going crazy anymore. It was kind of working before, but now our physics within the Y is perfectly fine. Okay, and press escape, unlock it. Okay, so we've now got our first-person camera working. We've got some mouse sensitivity, we got some rotation, we got move direction stuff going on. Let's go ahead and get a little bit fancier and allow us to adjust these volumes, not in code, but in the editor itself. So down here on line 48, I hard-coded right here 1,000 and move speed. Let's go ahead and create a public move speed. And let's set this equal to float equal to here. We'll just not set it to equal to anything. Here, we'll change this to move speed. And we've got our mouse sensitivity. Let's go ahead and make this public and take away its value. And save. Right here. So what have I just done? I've made these two fields right here, line 16 and 17, mouse sensitivity and move speed, to be public. Since they're public, let's go ahead and let Unity catch up with me. Notice I can now access them within the inspector view. So mouse sensitivity was set to 15, and we set our movement speed. Let's change it to 800, for example. Not 8,000, 900. Press the 9 on accident. So let's go ahead and run this. And we can say, oh, movement speed, it's kind of okay, I guess. Okay, I'm out of this. Maybe I want it to be 1100. 1, 0, 0. And so now I can mess with the move speed without going into the code and changing it. I've just made it public to access it outside of the code. And notice it's just whatever I change it to, and I can also mess with the mouse sensitivity in the same way, adjusting its values, without needing to go into the code and changing it. We could also, if we wanted, change these values right here on line 40 are basically limits of turning of negative 60 degrees to positive 60 degrees if we really wanted to. We could change it to something like 70 or 75 to give us sort of a greater effect of turning, but 60 feels okay. But again, we could adjust those values and make them public. Well, so this has been a review of creating a first person camera within Unity. Now, there are a number of things we could add to this and perhaps even optimize, but this will get us going. This will provide the basic first person perspective as well as a plane and cube, as we saw, that we could interact with. So, for example, if we interact with our cube, we see we run into, no matter how much I push W, run into the edge of the cube and could run into that. And I'm also not passing through the plane as well because of its collisions. So some basic collision stuff going on with the plane and the cube with the box colliders and a capsule collider on the player game object, but with its rotations, its constraints set to not rotate on the X, Y, or Z, so we don't just roll around in the scene when we start to move. But this has been a review of first-person camera within Unity. The complicated part is basically just these calculations right here of understanding Euler angles. Euler being a person's name who came up with, one of several people, in fact, who came up with ways of understanding rotations of an object within greater world space. And what we just say is, hey, go ahead and do these Euler calculations for us. So we're doing rotations on the object instead of rotations on the space. And if you put your cursor over these, it's say the rotation of the transform relative to the transform rotation of the parent. In other words, we just tell Unity to do the math for us, and it will take care of all of that. But then as we saw right here, we could also normalize movement as a vector right here based on whatever Unity assumes the transform right and transform forward to be, which we saw was in ours, the Z plane for forward and the Z axis for forward and the Y axis for right and left. But the rest of this code will, and again, this is fixed update as part of the physics system, allows access to first person camera within all of this. There are improvements we can make, as was mentioned. You could add things like crosshairs and other things, but this will produce the initial first person camera and allow sort of initial collision stuff without anything else going on.